Hello viewers, in today's lecture we are going to take up the concept of angle between two lines. In our earlier videos we have seen the concept of line in space, and we have also derived the vector and Cartesian equation of a line in space. So here we will consider how to find the angle between two lines. So let the vector equation of two lines, let the vector equation of two lines be vector r is equal to vector a1 plus lambda b1, and the vector equation of the second line is a2 vector a2 plus mu b2, right? Now let this is the first line, say L, and this is the second line L2, right? Or we can say this is L1 and this is L2. So this is line L1, this is line L2, and let theta be the angle between these two lines. So here theta is the acute angle between the lines L1 and L2. Now viewers, we know that here this line L1 is parallel to the vector b1, and this line L2 is parallel to the vector say b1, it is b2, and this line L1 is parallel to vector b1, and this line L2 is parallel to vector b2, and this line L1 passes through the point a1, or we can say this line L1 passes through the point say A, whose position vector is a1, right? And this line L2 passes through the point B, whose position vector is a2, right? Okay, now our aim is to find the angle between these two lines. Now L1 is parallel to vector b1, and L2 is parallel to vector b2. Now since these lines being parallel to b1 and b2 respectively, so angle between these two lines must be equal to the angle between b1 and b2, right? So the angle between L1 and L2 is equal to the angle between the vectors b1 and b2, right? Now from the concept of scalar product of two vectors, we know that b1 dot b2 is equal to this is the magnitude of b1, magnitude of b2, and cos of theta, right? So therefore cos theta is given as b1 dot b2 divided by the product of the magnitudes of the two vectors b1 and b2. So this is the formula for finding out the angle between these two lines L1 and L2. So here we can write theta is equal to cos inverse b1 dot b2 divided by mod of or the magnitude of, it is magnitude of b1 multiplied magnitude of b2, right? So this is the required formula. Now viewers, let us take two conditions. The first one is the condition of perpendicularity, and the second one is the condition of parallelism, right? So these two lines, L1 is perpendicular to L2 if theta is pi by 2 or 90 degree, then cosine of theta, that is cos pi by 2, should be 0, right? So in that case cos theta is 0, and when cos theta is 0, this whole term becomes 0. So therefore we get b1 dot b2 is equal to 0, right? So when two lines are perpendicular, then b1 dot b2, that is vector b1 dot vector b2, must be 0, right? And if we denote vector b1 by say a1 I cap, then b1 j cap, and c1 k cap, and vector b2 is say it is a2 I cap plus b2 j cap plus c2 k cap, then the dot product of vector b1 and b2 gives us a1 a2 plus b1 b2 plus c1 c2 equal to 0, right? So this is the another form when the two lines are perpendicular, right? Now let us consider the second case when the two lines L1 and L2 are parallel. So if L1 and L2 are parallel, then theta is either 0 degree or it is pi. So we can say that the vector b1 is lambda times of vector b2, right? Here lambda is some scalar, and when L1 is parallel to L2, then this vector b1 may be a scalar multiple of this vector b2, right? Now from this vector equation, that is b1 vector is equal to lambda b2, gives us, if we substitute this value here, we have a1 I cap plus b1 j cap plus c1 k cap is equal to lambda times a2 I cap plus b2 j cap plus c2 k cap, right? Now if we compare the I cap components, or the coefficient of I cap, j cap and k cap, or in other words we can also say that if we compare the x components on both sides, y components on both sides, and z components on both sides, we get a1 is equal to lambda a2, b1 is equal to lambda b2, and c1 is equal to lambda c2. And from these three equations we have a1 divided by a2 is equal to b1 divided by b2 is equal to c1 divided by c2, right? And this is equal to lambda, and lambda is a scalar, and this is the condition for the parallelism of line L1 and L2. Now viewers, if instead of vector equations, if we have the Cartesian equation of the two lines L1 and L2, then we know that A1, B1 and C1 are the DRs of this line L1, and A2, B2, C2 are the DRs of this line L2, right? So we can write the DRs of line L1 are A1, B1 and C1, right? And the DRs of line L2 are A2, B2 and C2, right? And if theta is the angle between these two lines, then we know that cos theta is equal to vector b1 dot b2 divided by the magnitude of vector b1 times magnitude of the vector b2. Now b1 dot b2 can be written as a1 a2 plus b1 b2 plus c1 c2 divided by the square root of a1 square plus b1 square plus c1 square multiplied by a2 square plus b2 square plus c2 square, right? So this is the formula for finding out the angle between two lines, right? So viewers, let us take some problems. Now viewers, let us find the angle between these two lines. So here this is line 1, this is line 2, and we will compare this line with this standard form, and we'll compare this line with this standard form. And we know that the angle between these two lines is theta, and cos theta is given by this formula, right? Now here we have a1 a2 plus b1 b2 plus c1 c2. So here we have a1 is 3, a2 is 1, so we have 3 into 1, then we have 5 into 1, then we have 4 into 2, right? Divided by the square root of a1 square plus b1 square plus c1 square. So we have 3 square plus 5 square plus 4 square, and then we have 1 square plus 1 square plus 2 square, right? Now simplifying this expression, we have 3 plus 5 plus 8 divided by this is 9 plus 25 plus 16, and this is 1 plus 1 plus 4, right? Now this is 16 divided by root 50 multiplied by square root of 6, right? Now this can be further simplified as 16 divided by 50 into 6, and cos theta can be written as 16 divided by 300, which can be written as 16 divided by 10 root 3, and this can be written as this is 2 8s are, this is 2 5s are, so we have 8 over 5 root 3. So therefore theta is cos inverse 8 divided by 5 root 3, right? So this is the angle between these two lines. Now let us find the angle between these two lines, and in this case the equations are given in the form of vector equation, right? So here the first line is a1 vector a1 plus lambda times vector b1, and the second line is vector r is equal to vector a2 plus mu times vector b2. Clear? Now here this is this vector is a1, and this vector is vector a2, and this vector is vector b1, and this vector is vector b2, right? So if theta is the angle between these two lines, then cos theta is equal to b1 dot b2 divided by mod of or the magnitude of b1 and magnitude of b2, right? So viewers, here we will find b1 dot b2. So this is b1 and this is b2. So here we have 1. So this is 1 multiplied 3 plus here we have 2, here also we have 2. So this is 2 into 2 plus this is 2 times 6, right? Okay, and divided by the magnitude of vector b1 is 1 square plus 2 square plus 2 square, 1 square plus 2 square plus 2 square. Then the magnitude of vector b2 is square root of 3 square plus 2 square plus 6 square, and if we simplify this expression, we have 3 plus 4 plus 12 and divided by here we have square root of 49, sorry, here we have 9 and here we have 49, right? So this is equal to this is 19, 3 plus 4 plus 12, this is 19, and here we have a square root of 9 as 3, square root of 49 as 7, so we have 19 divided by 21. So this implies that theta is equal to cos inverse 19 divided by 21. So this is the required angle between these two lines. Now viewers, let us take this important problem. Here we have to show that these two lines are perpendicular. Now if we compare these two lines with the standard form, that is x minus x1 divided by a1, y minus y1 divided by b1, z minus z1 divided by c1, and x minus x2 divided by a2, y minus y2 divided by b2, z minus z2 divided by c2. So the direction ratios of this line, the first line, are 7, minus 5 and 1, and the direction ratios of this line are 1, 2 and 3. Now we know that two lines L1 and L2 are perpendicular if A1 A2 plus B1 B2 plus C1 C2 is equal to 0, right? So these two lines are said to be perpendicular if the value of this expression is 0. So let us find this expression. So A1 A2 plus B1 B2 plus C1 C2 is equal to C, and this is A1, so, and this is A2, so 7 into 1 plus minus 5 into 2 plus 1 into 3, right? Okay, now we have 7 minus 10 plus 3, so this is minus 3 plus 3, that is 0. So therefore these two lines are perpendicular. Now let us take this problem. If the lines this line and this line are perpendicular, find the value of lambda. Now viewers, in the previous example we have seen that the line L1 is perpendicular to L2 if and only if A1 A2 plus B1 B2 plus C1 C2 is equal to 0. Now here this is A1, B1 and C1. The direction ratios of this line are minus 3, 2 lambda and 2, and the direction ratios of the second line are 3 lambda, 1 and minus 5. So let us substitute these values in this equation. So we have minus 3 times 3 lambda plus 2 lambda times 1, then C1 is 2 times minus 5, that is equal to 0. So this is 9 lambda, minus 3 times 3 lambda is minus 9 lambda, plus this is 2 lambda minus 10 is equal to 0. So this is minus 7 lambda minus 10 is equal to 0, and minus 7 lambda equal to 10. So lambda is minus 10 divided by 7, right? Now viewers, let us take this problem. Here, if the lines, this line and this line are parallel, we have to find the value of lambda. Now here let us say this line is L1 and this line is L2, and if L1 is parallel to L2, then we have this condition, that is A1 by A2 equal to B1 by B2 equal to C1 by C2, or in other words we can say that the direction ratios of the two lines must be proportional. Now here we have the first line L1, that is x minus 1 divided by minus 3, but here we have 2 minus y, so we'll have to reduce it into the standard form, so we must make it y minus 2, right, and taking the negative sign to the denominator, and then we have z minus 3 divided by minus 4. Now the drs of this line are minus 3, minus 2 lambda and minus 4, because before writing the direction ratios we have to see whether the given line is in standard form or not. The standard form, by standard form we mean that it should be in the form x minus x1 divided by a1, y minus y1 divided by b1, and z minus z1 divided by c1, right? So here we have 2 minus y, but here we have y minus y1. So we must change this expression 2 minus y to y minus 2. Now the second line is x minus 1 divided by minus 6, and again see here we have 2 minus y, so we make it y minus 2 and divided by minus 5, right? And z minus 4 divided by minus 8. Okay, now once we have seen that the lines are given in standard form, we write the direction ratios a1, b1 and c1, and here we have a2, b2 and c2. Now substituting these values here, we have a1 by a2 means minus 3 by minus 6, then we have minus 2 lambda divided by minus 5, and then we have minus 4 divided by minus 8, right? Now this gives us 1 by 2, 2 lambda by 5 and 1 by 2. Now taking any two fractions here, so we have 2 lambda by 5 is equal to half, so 2 lambda is equal to 5 by 2 and lambda is equal to 5 by 4. So this is the required value of lambda. Now viewers, let us take this problem. Here we have to find the values of p so that these two lines are at right angles. It means these two lines are perpendicular. Now here we will use the condition that a1 a2 plus b1 b2 plus c1 c2 is equal to 0, where a1 b1 and c1 are the direction ratios of this line, and a2 b2 and c2 are the direction ratios of this line. But here, viewers, we see that these two lines are not given in the standard form. So let us first convert these two lines. This is line L1 and this is line L2 into standard form, right? So what is the standard form? Standard form is x minus x1 by a, y minus y1 over b, and z minus z1 over c, where a, b, c are the direction ratios. So let us change this equation into this form, right? Now we can here we can write it as x minus 1 over minus 3. Then here we can take 7 common out of these two terms. So we have 7 times y minus 2 divided by 2p is equal to z minus 3 divided by 2. Now this can be written as x minus 1 divided by minus 3. Then we have y minus 2 divided by 2p divided by 7, and taking this 7 to the denominator of 2p, and here we have z minus 3 divided by 2, right? So now this equation is in this form, right? So this is a1, this is b1, and this is c1, right? Now let us similarly convert this line L2 into this form. So here let us take minus 7 common out of these two terms. So we have x minus 1 over 3p, and then here we need not change this term, and here we take minus common out of these two terms. So we have z minus 6, right, divided by 5. Now this can be written as x minus 1 divided by minus 3p over 7, right, taking this minus 7 to the denominator of 3p, and then we have y minus 5 over 1, and here we have z minus 6 divided by minus 5, right? Now viewers, this is a2, this is b2, and this is c2, right? Now we have to find the value of p, and we will apply this condition for two lines to be perpendicular, and we will substitute these values of a1, b1, c1, a2, b2, c2 in this expression, right? So let us substitute the value. So a1, a2 is minus 3 multiplied minus 3p divided by 7 plus we have 2p by 7 times 1, and then we have 2 times minus 5 is equal to 0, right? Now this is 9p divided by 7, 3 3s are 9, 9p plus we have 2p by 7 minus 10 is equal to 0. Now this is 11p divided by 7, 9p plus 2p is 11p divided by 7 is equal to 10, and 11p is equal to 70, 7 tens are 70, and p is 70 divided by 11. So this is the required value of p for which these two lines are perpendicular.